So we're going to work with composite transformations right now. So composite is a word that indicates two or more things put together. That's basically what it is. And so when we talk about composite transformations, we're talking about not just one, but two or three or four different transformations done together. So we'll do these in a specific order, whatever order. I mean, you can have it composite transformation in any order, but we will do it in the order that's presented to us. So on the test, you'll have problems like this. Maybe it'll be a translation first, and then dilation, then a reflection. Or you might have a rotation, then a translation. So the order can vary. What is important is you do each one of the transformations separately. You do that transformation, and then you move on. So we're going to start off with this triangle ABC, with the points 6, -3, 12, 6, and -6, 9. And we're going to use these three transformations. First, we're going to use a translation with this vector -3, 6. We're then going to dilate it. So this will be the first thing we do. We're going to start with this point right here, with these points right here, and we're going to find 3 new points from this translation. Then after we do that, we will no longer use this. We will have the new points, which we use on the dilation. So each time we just move over 1. So then we're going to use these new points to find the reflection. And where we end up is the transformation that you get as a composite with all 3 of these. So first of all, let's start with this translation vector. So this remember is a rule. It's not a point. So you look at these brackets, they're different than these. So this indicates a point or a location. This tells you a place. This is telling you directions, or it's a rule basically. So it's saying the point gets moved 3 to the left and 6 up. It's not saying that it is at 3, 6 or any one specific point. So this point will move the same as this, but they will both be in different locations when they are done. So after moving 3 to the left and 6 up, it'll be up here. This one will be up here. So what we will get is you will have your triangle, and I'm not doing a very good job, but this is just going to be quick. So we're going to move it over 3, like that, and up 6, like that. And so the triangle will then move over and up. As you can see, it actually goes off the page. So we're not actually going to graph it, but we have that representation at the top. We're going to find the points, and we're going to just use the rules algebraically, I guess, is what you would. So the easiest way to use this one is just to take your original point that we're going to be translating and put this underneath. So when we do that, you match them up. So this is not the x-coordinate, but it is the direction the x-coordinate will move. And this is the direction the y-coordinate will move. So we're going to start with the point, and we're going to move it 3 to the left, and so we can represent that by subtracting. And here, that's a positive, so we're going to add. So our new point will then be 3, 3. -3 plus 6 is 3. So that will be A prime. So we're going to go A prime, B prime, C prime. So A prime will be 3, 3. And we'll do the same thing with this one. So each time we're going to apply the same rule. So -3, 6. 12 minus 3, 9. 6 plus 6, 12. 9 comma 12. Negative 3, 6. So remember, this was not a point. This is the vector we're applying. So negative 3 minus 3, negative 9. Negative 9 plus 6 is 3. And again, this is now a new point, a new location. And you can see it has parentheses, not these brackets. So it's negative 9, 3. So you do each of the 3 points. Now you're done with the first step. So the next thing you should do is, when you're doing these, if you're careless or you're not careful enough, it's very easy to get confused and accidentally use the wrong points. So we're going to go to the next one, which is dilate, and we're going to dilate by a scale factor of 1/3. To avoid accidentally using these, make sure I use these, I'm going to just remove it. So there we go. There we are. So now what we're going to do is we're going to take this scale factor, which is 1/3, and we're going to multiply it by each of these. So remember what that is. So is 1/3 times 3. That'll be the same as dividing by 3, which would be 1. So 1/3 of. But you can also, if you get confused or you forget, 1/3 is 1 divided by 3. So we take that times 3 and we end up with a 1. So we're going to multiply 1/3 times 3, and that'll be 1. 1/3 times 3, again, that's 1. So this is for the first one, and this is for the second one. And now instead of A prime, we have a double prime. So 1 comma 1. B double prime, C double prime, etc. So we're going to do it the exact same way for all of those. We'd say 1 divided by 3, that's 0.333, times 9, and that gives you 3. So what you'll get for this is 3 comma 4. This one will be negative 3 comma 1, and that's your next point. So we're almost done, but not quite. So now we have the last one, which is reflect y equals x. So cover that up. We only want to focus on these right here. Now the rule for reflecting a line across the line, reflecting a point across the line y equals x, negative x, is this. So x comma y, whenever you reflect across the line y equals x or x comma y, the coordinates change place. And if it's the line y equals negative x, then you also change the signs. Okay, so try not to think of these as negatives. We talk about it as negative y or negative x. Think of it as opposite. Because if you think of it as a negative, sometimes you might get confused and think that the answer has to be a negative number. It doesn't have to be a negative number. It has to be the opposite of whatever it was. So if we start out with a positive, well, the opposite of a positive is a negative. So what we're looking for here, we want x to the opposite of x, and we want y to the opposite of y. But this will go here. So if we look at y, it is 1. The opposite of 1 is negative 1. So you put negative 1. And the same thing for the second one. So you change both signs. There it is. This one, same thing. Be triple prime. It'll be 4 and 3. So you switch the locations. of X and Y, change the signs. C triple prime, again, coordinates switch locations, 1, -3, and now we want the opposite of that. The opposite of positive is negative. The opposite of a negative is a positive. And that would be the final answer. So that's how you go through and translate a composite transformation. You just, whatever one you do, you just focus on one at a time. Once you find the new points, you forget about the old ones and move on. And then you forget about the old ones, move on.